Okay then, good day ladies and gentlemen. I am trying to put together some videos to talk about how we can use manipulatives to support making sense of mathematical ideas and mathematical processes and procedures. And the one I want to talk about today with you is the formal division algorithm, or the short division algorithm. We're not going to talk about long division for this. So the formal short division algorithm. And to do that, we're going to look at a particular division. We're going to look at the division 462 divided by 3. And the model for division that we're going to use to sort of talk about this and to make sense of this is to think about that as sharing. So I'm going to share 462 into 3 equal shares. And what we can see here is I've set up the number 462 using Dienes Blocks, or Dienes Blocks. The proper pronunciation, I'm reliably informed, is Dinesh, but many people will know them as Dienes Blocks. Now, you don't have to use Dienes Blocks for this. You can use place value counters. You can use multi-link even as well for something like this, provided you have enough of it. But this is the manipulative that I'm going to use. So the idea is I have 400s. You can see them there lined up, 1, 2, 3, 4. I have 6 10s. I have 2 1s. So I have 462. And I want to share this into 3 equal shares. So what I'm going to do is I'm going to take my hundreds to start with. And the reason I'm taking my hundreds to start with is because I know that if I don't have enough hundreds to fully complete my shares, then I'm going to have to exchange those hundreds down for tens. And we can see that that's exactly what's happened here. I have my 400s. I can share 100 into each of my 3 shares, but then I have this leftover 100, which I can't share into my 3 shares equally in its current form. So what I'm going to do is I'm going to take that 100 and I'm going to exchange it for 10 tens. And if we look at what that looks like on the formal division algorithm, we can see that what that looks like in the formal division algorithm is if I'm sharing 462 into 3 shares, then I can put one of my hundreds, I can put 100 in each share, but then the 4th 100 I'm going to exchange for 10 tens. And having these 10 tens plus my original 6 tens means I'll have 16 tens altogether. And now I'll proceed in exactly the same way. I'm going to share my tens now across my 3 shares. So I can put my tens here, 1 10 there, and 1 10 there. And I can keep going with that. I can do that again. A 10 there, a 10 there, and a 10 there. Oh, those two are slightly off. There we are. And I can do that again. And I can keep going until I have not enough tens to share equally across my 3 shares. And that's going to happen when I get to the end of this share. And now I don't have enough tens left to share across my 3 shares. So how many tens have I managed to put in each share? Well, I've managed to put 5 tens in each share. But I have this 10 left over that I can't share across those 3 tens across those 3 shares in its current form. So again, what I'm going to do is I'm going to exchange that, not drag it. I'm going to exchange that for 10 ones. And now I have these 10 ones plus my original 2 ones, so I have 12 ones altogether. And again, what I can do now is I can go about sharing those 12 ones equally across my 3 shares. So I can share those ones. I can share those ones. and I can keep going. And in this case, of course, because I've chosen my numbers carefully, I can keep going until all of my ones are shared and I have no ones left over at all. And so how many ones have I put into each of those three shares? I put 4. And so now I can see that each of my three shares contains 100, 5 tens, so that's 50, and 4 ones, so that's 4. And that's replicated in the second share, and that's replicated in the third share. So this is how we might make sense of what's happening in the formal division algorithm, certainly the short version of the formal division algorithm, using manipulatives. And like I say, you don't have to use the Dienes block manipulative there. You could use place value counters as long as pupils understand that a single 100 counter will exchange for 10 tens and a single tens counter will exchange for 10 ones. Or you can use multi-link if you have enough multi-link to build 462 out of individual blocks. So I hope that's been useful in showing you how you might use this manipulative to help make sense of this mathematical procedure. If you have any ideas for any other videos that you think you would like me to create to look at a particular mathematical idea and how we might explore it by manipulatives, please do give me a shout. As always, I'd like to say thank you to MathSpot and its creator, Jonathan Hall, for providing the virtual manipulative. If you've never been onto MathSpot before now, please do make sure you go and have a look. There are some great things there, not just the virtual manipulatives, but all sorts of loveliness on that site for teachers of mathematics.